Now let's take a minute and explore this notion of higher order derivatives. So we know that we might, if we have a function like this, let's suppose that we have x to the fifth. We know that the derivative for x to the fifth would be 5x to the fourth. Yeah. But what if we start from here and say, well, what is the derivative of this? The derivative of f of x equals x to the fifth is 5x to the fourth. But what is the derivative of f prime of x? In other words, what is the derivative of this? Well, that would be called the second derivative. In other words, I just differentiate again. So this case would be, now I just use the power rule over. 4 times 5, that's 20. X to the third. And then I could say, well, what about the derivative of that? Well, that would be 3 times 20, which would be 60, x to the second. Yeah, and then I could say, well, what about the derivative of that? And notice, I run out of room up here for prime, so maybe I'll just write the fourth derivative. Maybe I'll just do this. Put a little 4 up there and say this is 120 x to the first. Let me go ahead and put the x in there. I've been putting the x in there. So this is going to be 120 x. And then I could go again, I can say, well, what about the fifth derivative? And you see, we're getting these higher order derivatives. So this would be 120. And then notice the sixth derivative is just going to be 0 because I'm differentiating a constant. There. So when we talk about higher order derivatives, it's not a complicated thing. It's just you're differentiating again, repeatedly. Now, there is some different notation. Notice that I talked about f prime of x. Well, that's when we take the derivative of what we already differentiated, right? So you can think of it this way. Here's my first derivative, and I'm differentiating that. And that kind of lends itself to this notation. Like that. That kind of lends itself, right? It kind of looks like we're multiplying. But this is the Leibniz notation for the second derivative. And we could say, well, what about the fifth derivative? Well, in other words, if I'm talking about the fifth derivative, that would be a little 5 up here, and then a dx like that. Yeah, that would be the fifth derivative. So this is some notation. So let's suppose that we want to find the third derivative of this thing. Let's suppose that we've got y equals x to the seventh, and we want to find the third derivative. Well, here's the first derivative, which is 7x to the sixth. And then what about the second derivative? Well, and I'll just, this is going to be 6 times 7, x to the fifth. See? That's the second derivative. And what about the third derivative? Well, 5 times 6 times 7, x to the fourth. There we go. Yeah. So the higher order derivatives are not complicated. You're just taking what you know about differentiation and applying it over and over again. And these have some applications, like you have, you think of you have a position function. The derivative of that would be the velocity. The derivative of velocity would be acceleration. So there's some applications here that we can explore later.